Welcome to geometry. So we've been working on proofs and proving that two triangles are congruent. Well, we're going to continue that idea, but this time we're going to talk about proofs about that involve partitioning. Okay, so partitioning just means breaking things up. Okay, so it just means how do we break things up? And so we have here five axioms. We have actually four axioms of equality. And the axioms are stuff like definitions, theorems. Okay, you can categorize them in that family. And so we're going to talk about the spatial awareness. Okay, so here's the first axiom, okay? Let's talk about this first axiom. The whole is the sum of its parts. And that is exactly what it means. There's nothing else to that. If I have a whole, I can represent it as different parts. For example, if I have this segment down here, AC, well, I can represent it as the sum of its parts. I can say AC is the same as AB plus B plus BC. Okay, that is the whole. The whole is AC, is the sum of its parts. Done. Okay, okay, great. So we have the second one, which is substitution. Here is substitution. Equals can be substituted for each other in any equation. I think we all know what substitution means. Well, this means that if I have 2x and I know that x equals 5, well, then I can always say that 2 times 5 is equal to 10, right? That is the substitution there, okay? And then we have addition axiom and subtraction axiom. Well, if I have 2x plus 5 equals 7, then I can use the subtraction axiom to do minus 5 minus 5. And again, these are still going to be equal because the same as addition, right? Because equals added to equals results in equals. Okay, so here an equal subtracted to equals results in equals. I know that's very wordy, but here it is, right? You can take this out and I still have 2x equals 2x equals 2. The equals did not disappear. Okay, great. And then we have the same thing for addition. Okay, well, if we go on to this proof down here, and we're given this piece, and we're supposed to prove this, okay, well, let's start with what you're supposed to prove in this case. I'm supposed to show that AC is equal to BD. This is the goal, okay? Given that, right, we're given this piece here. Okay, well, let's start off with one side. If this is all about partitioning, this worksheet is all about partitioning this unit. And so we say, okay, well, AC, how do I represent AC? And we spoke about that before. Well, AC is equal to AB plus BC. Yes? Okay, yeah, that's great. And we also know that BD is going to be equal to, right? BD is equal to BC plus CD. Awesome. And I can do this because the whole is the sum of its parts. That is the reasoning for that. Okay, well, how do I continue this? Well, I notice here that BC is uh, in both of these equations. Here's a BC and here's a BC. So I can take the top equation. I have a system of equations now. Back from algebra, I have the top equation and I need to solve for BC. I need to solve for BC. So I say here that AC is equal to AB plus BC. Well, the way I solve for BC is simply by subtracting AB on both sides. Minus AB, I end up with AC minus AB is equal to BC. Great. Well, now that I have BC, I can take BC and substitute it right in here. Because the whole point is for me to solve for, is for me to get to this, right? And I already have here a BD. And when I substitute this in BC, now I'm going to have AC as well in that equation, okay? So when I have two things that are equal, when I have two variables in both equations, I solve for one and I substitute it into the other. So I have this idea, and therefore this equation here becomes BD is equal to, again, making that substitution right here, I have that BD is equal to AC minus AB, right, plus CD, right? And I'm almost done. Notice I almost have it, that AC equals BD. Only thing is, if I could possibly cross out, I want to keep the BD and I want to keep the AC. The things that I want to get rid of is AB and CD. And what's the relationship between AB and CD? Here's the relationship. AB is DC. So, applying this substitution here, I end up that BD is equal to AC minus, well, this BD, AB, I can substitute it for a CD. So I'm just going to say CD here plus the same CD. And there it is. And what happens now? Well, these two terms go away, right? These two go away and I end up with my answer. This is what I wanted to prove. There it is. BD equals AC. Done. Okay? Now, let's move on to the second one, which is the same thing. Here we broke up a segment, and on this one, we're going to break up an angle. Okay? Notice this symbol, which means perpendicular, right? And all it means is that you have a 90-degree angle. Well, in this case, I have two perpendiculars, therefore I'm going to have two angles. Notice that it says that SU is perpendicular to SW. And here is SW. Therefore, I have a right angle right there. And next, I also have a right angle at ST and SV. And so my right angle is right there. Two right angles, okay? And I need to prove that the measure of angle 1 is equal to the measure of angle 3. Here we go. Well, I need to represent a whole in terms of its parts. So let's represent the whole in terms of its parts. Well, I know that the measure of angle 2 plus the measure of angle 1 is how much? How much is the measure of angle 2 plus the measure of angle 1? Notice, this is that one right here. Angle 2 plus angle 1 is equal to 90 degrees. And I also know that the measure, of angle 3 plus the measure of angle 2 is equal to 90 degrees. And it's right here. 3 plus 2 is 90. Okay, well, in this equation, I have two things that are equal to 90. I have this piece that is equal to 90, and I also have this piece that is also equal to 90. So look at what I'm going to do here. Instead, I'll say the measure of angle 3 plus the measure of angle 2 is equal to, yes, I know it's equal to 90, but instead of writing 90, I know that 90 is also up here and it's equal to this thing. So I'm going to say it's equal to the measure of angle 2 plus the measure of angle 1. What do I do here? Well, combine like terms, right? These are my two terms that are equal, these two terms. So I do minus the measure of angle 2 minus the measure of angle 2 on both sides. And I end up with, right, the measure of angle 3 is equal to the measure of angle 1. And that is what I set out to prove. Done. Right? So let's think about it. This reasoning here was because the sum, the whole is parts of the sum, right? This is that axiom. This axiom right here, right, is the substitution axiom. This axiom down here, right, that's the subtraction axiom. And that gives us the answer at the end, okay? So we use here three axioms. The whole is the parts of its sum, substitution, and subtraction, okay? So in this question, I'm only gonna set it up for you, right? We're back to proving our triangles. You gotta think about everything we've used, right? So in general, we refer to breaking a segment or an angle into its component parts, okay? So in this case, I need to show that this is true. But again, I have two triangles here that I need to prove are congruent, right? I have that triangle and I have the other triangle. And I need to prove these two triangles are congruent before I can prove this, because of course, this is going to be true by CPCTC. What this is saying is that if the two triangles are congruent, then all of its corresponding parts have to also be congruent. Remember, we have three ways of showing that triangles are congruent. We have side, 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 and angle, side, angle. So your last line is going to be this statement with this reasoning, okay? But I first have to prove that the triangles are congruent. Let's see what the given says. We have that BC is congruent to FD. We also have that angle 1 is congruent to angle 2, and that AD is congruent to EC. Great. Well, what is all this saying? If I take this piece out here, and I say, well, here's angle 2, and I know that this piece is also congruent. So I know that this is a side, this is an angle, and they also gave me a piece of information about BD. I know something about here. I know that BC. I know BC is going to be congruent to the other piece of the triangle. So I think what they're trying to say is that I need to prove that BD is going to be congruent to this segment right here. I think that's what they're trying us to get. So if I can show that BD is equal to CD, then I'm all set, and I'll have the two triangles congruent by side angle side. So show me that in your proof, just like we did before. Show me that BD is equal to FC. If we can show me that, then you'll have side angle side, and then you can say CPCTC here. Okay, remember, this is going to be similar to this proof. Okay, well, all we're doing is partitioning. It's going to be similar to this one here. Okay, good luck.